Okay, so if you're someone who trains those huge, large-scale AI models, you know the struggle, right? But what if your code could get way simpler? Your training could run faster, and your models could get even bigger, all on the same hardware you have right now. Well, DeepSpeed just dropped two major updates that promise to do exactly that. Let's break them down.
So picture this, you're in the trenches, you're working on the next big thing in AI. Maybe it's a multimodal model that has to understand both pictures and text, or maybe you're fine-tuning a massive language model. If that sounds like you, then you have almost certainly felt some very specific frustrations.
Does this look a little too familiar? On one side, you've got these training pipelines that get so complicated, they become a total nightmare to code and debug. And on the other, you're in this constant war against that dreaded out-of-memory error because our models just keep getting bigger and bigger. Yeah, these are the two big headaches we're going to talk about today.
The good news is, it looks like the team over at DeepSpeed has been feeling our pain. They've just rolled out two really elegant solutions designed to tackle these exact problems head-on. So first things first, let's see how they're planning to untangle our code.
First up, the coding maze. And you know exactly what I'm talking about if you've ever tried to stitch multiple models together, say a vision encoder and an LLM, into one big training pipeline. Things can get complicated really fast.
So here's where things used to get super messy. The original DeepSpeed API could only handle a single number, a scalar, for its backward pass. But with these complex models, you often need to pass whole arrays of error signals back and forth between different parts. The old API just wasn't built for that, which forced everyone into these really clunky, bug-prone workarounds. It was a mess.
And wow, this slide just says it all, doesn't it? I mean, just look at the difference. On the left, you have the old, kind of clunky, DeepSpeed-specific way. And on the right, that's just clean, simple, native PyTorch. You can now build these incredibly sophisticated training patterns using the exact same command you already know. It's just that simple. DeepSpeed takes care of all the crazy parallelization stuff in the background, so you don't have to worry about it.
This quote here really nails it. This isn't just some technical tweak, it's really a change in philosophy. The whole goal is to make DeepSpeed feel less like this big, complex framework you have to learn, and more like a supercharged version of the vanilla PyTorch that we all know and love.
And the payoff for all this new flexibility isn't just about writing cleaner code. By making it easier to do more advanced workload splitting across GPUs, this new API actually unlocked a massive 30% training speed up on a really complex multimodal model. That is a huge win. Okay, so they've helped us untangle our code. Awesome. But what about that other big headache, the memory hog? You know, that constant pressure of your model's parameters and optimizer states just eating up every last gigabyte of your precious GPU memory.
So where does this memory problem come from? Well, it all comes down to precision. To make sure everything was numerically stable, DeepSpeed traditionally kept a master copy of everything, your parameters, your gradients, in full 32-bit floating point, or FP32. Now that's the safest way to do it, but it is incredibly memory hungry.
So DeepSpeed's solution is basically a memory diet. First, you can now tell it to store all those model states in a lower precision format, like bfloat16. And second, it plugs right into PyTorch's autocast. Think of autocast like a smart gearbox in a car. It automatically shifts up to higher precision when it's doing sensitive math, and then shifts back down for everything else. You get the memory savings of low precision, but the quality and stability of high precision. It's the best of both worlds. And the results? Honestly, they're pretty staggering. Just look at this chart. For a 7 billion parameter model, the old way, with high precision states, topped out at over 31 gigs of memory. But by flipping the switch to low precision, that drops all the way down to under 19 gigs. The picture here really tells the whole story. I mean, let's just pause on that for a second. That's a 40% drop in peak memory. For a lot of us, that's the difference between a training run actually finishing or crashing halfway through. This literally means you could train a much, much bigger model on the exact same hardware you have sitting on your desk right now.
Okay, so right about now, the skeptic in all of us is probably asking the right question. What's the catch, right? Anytime you hear low precision, you have to wonder if you're sacrificing model quality to get all those memory savings. And it's a super important question to ask.
And here's the answer, straight from the data. After 1,000 steps, the final loss for the baseline model was 3.09. For the low-precision model, 3.12. I mean, that difference is so small it's basically noise. This is the proof. You can get all of those incredible memory savings without any real meaningful hit to your final model's quality.
So, when you take a step back and look at these two updates together, what does it all really mean for you, the developer? Well, it means you've basically just been handed two new training superpowers. So let's boil it all down. First, you get to write code that's way cleaner and more intuitive. It's just PyTorch. And you might get a 30% speed boost for your trouble. And second, you can slash your memory usage by 40%, which opens the door to training much bigger models without needing a single hardware upgrade.
And really, that's the bigger picture here. These aren't just small incremental updates. They're fundamental improvements that are lowering the barrier to entry, making it more efficient and more accessible for everyone to get involved in building state-of-the-art AI.
Which, of course, brings us to the final question, the one that really matters. Now that you've got these new tools in your toolkit, making training simpler, faster, and way more memory efficient, what new ideas are you going to explore? What problems are you going to solve? What are you going to build next?